Hey folks, this is Jay here from Chandler, Arizona. Let's continue our journey in learning what is quantum. Like I said in my last two vlogs, uh, quantum is also called quantum mechanics. It's a field where we study different industries and processes around us at an atomic and at a subatomic level, where we are actually trying to understand, for energy we are trying to understand how the photons interact, and for mass we are trying to see how the electrons interact, and those are kind of the smallest unit we know till date, and how they interact. There are four more fields in quantum mechanics. There are four fields in quantum mechanics, four pillars, so to say. Quantum computing, which tries to solve problems which are not solvable in a classical computer. Quantum cryptography, which uses quantum materials or quantum mechanics to secure our communication channels and make it immune to hacking. Quantum sensing, which is basically sensors used to measure physical materials at a much more minute level, which includes measuring pollutants and things like that. And last but not the least, quantum materials, which is basically materials which have properties uh, which classical materials do not exhibit. For example, conducting electricity without resistance. Today, if you see a semiconductor, it is semiconductor. It's not superconducting. So quantum materials are materials which can exhibit properties which are not exhibited by classical material properties. Quantum computer is basically has basically three key features overall. One is quantum superposition, which basically tells us that a particular qubit, which is an equivalent of a bit from classical computers, a qubit can be multiple states at the same time, and you will have to use probabilistic methodology to figure out what it is at a particular time. Number two is quantum entanglement, which basically is a process where one qubit is dependent or entangled with another, and its states are determined for those dependencies. Quantum tunneling, which means that multiple qubits can tunnel information through barriers that would stop information between those qubits, something which has no equivalent in a classical computer and between two bits. But saying all that, and today's focus for quantum is that there are still, quantum is a brand new field. There are still some limitations and challenges in the quantum computing field. Number one challenge, which everybody is working on, from Google to IBM to Microsoft to whoever is working on, is to create stable qubits. Qubits is very sensitive to noise, to temperature. They need to be kept in extremely cold environment, otherwise it becomes very, very noisy. What that means is it is not easy to predict or determine what value it is storing at a particular time. That's number one. The second challenge just now hurting quantum computer is to scale the quantum computers up in terms of number of qubits. Today, it has only been scaled up to thousands of qubits, and the only way to make quantum real to some of the current domains like optimization and cryptography or healthcare or drug discovery is that those qubits scale up in millions so that they can solve some problems which are hurting human beings right now. And last but not least is the need for developing algorithms. Once again, as usual, hardware can only get you somewhere, but software is the one which eventually takes these computers to every single desktop in the world. And there is a need for creating algorithms which can standardize the hardware below it, regardless of what particular hardware technology you are using to demonstrate quantum mechanics in a computer. These algorithms are also needed to simulate our life processes or optimization processes in a certain way, so that multiple combinations can be tried out. Despite these challenges, there is a growing optimism that the future of quantum computing is very, very bright. Almost every expert I have talked to believe that quantum computers are going to have a major impact in a lot of industries, which includes Web 3.0 technology, it includes healthcare, it includes optimization, it includes cryptography. Thank you very much. If you like this blog, please like, share, and subscribe. Thank you.